So good day everyone. I am here again for another tutorial, but this time I will teach you how to use the squeeze theorem or the sandwich method. So I have here an example problem. So we have the limit of x approaches to 0, x squared times cosine 1 over x. So from here, we have to understand the behavior of this cosine. So as you know, cosine oscillate between -1 and +1. From there, we can get the inequality. So we have -1 is less than or equal the cosine 1 over x less than or equal 1. So in short, we have the cosine 1 over x is greater than or equal -1 and less than or equal +1. So since we have x squared here that is being multiplied to our cosine 1 over x, we're going to multiply it as well to our inequality. So from there, we have -x squared less than or equal x squared times cosine 1 over x less than or equal x squared. So this is our final inequality. So from there, we can get its limit, which is the limit of x approaches to 0. So can write it like this. We have limit of x approaches to 0, -x squared less than or equal limit of x squared cosine 1 over x, just again x approaches to 0, and less than or equal limit of x approaches to 0 x squared. So from there, we have to substitute the 0 here to our x again. So this one, we will not be changing this one, so it will stay like that until the end. So let's simplify. So let's substitute rather. So we have -0 squared less than or equal the limit of x squared, which is x approaches to 0, cosine 1 over x less than or equal 0 squared. So in short, we have, so let's simplify it again. So we have 0, -0 or 0, it's still the same. So we have 0 less than or equal limit of x squared, which is x approaches to 0, cosine 1 over x less than or equal 0. So let's analyze our answer. So from here, we can say that the limit of x squared, which is x approaches to 0, cosine 1 over x must be greater than or equal -0 or 0 and less than or equal 0. So in short, there is no other answer. We have the limit of x approaches to 0, x squared times cosine 1 over x is equal to 0. Therefore, this is our final answer. Thank you so much for listening.